So what I'm going to do, guys, today, just a quick reminder. Please work on your load calculation. I think we did good. I think we did good job yesterday, guys, walking you through the Excel sheet. I will be available to walk you individually through the Excel sheet too, if you want to add and do certain things. By the end of the day, please print your load calculation to the best of your ability, as well as your project schedule on 22 by 34, on 11 by 17, the project schedule. Okay, so print these two before you leave. As we did in the past, guys, on Fridays, you can leave at noon if you want to go to work, but not before that, please. Fridays. So you're going to stay here, I'm here, but if you're going to leave at noon, that's fine with me. So that's what we're going to be doing. Let me go over, if I don't have any full 100% agreement, guys, I will continue with 2008, because that's the plan that we had, is to continue with 2008 code book. There isn't major changes, guys, except the tables. They shifted the tables from 310.15, 310.60, 310. What's the table?
15.b.
.15b16. So they shifted them .b16. Okay, let's go ahead and take this example, my friend. Example number 1. And I hope this is directly related to what we're doing, guys, in calculation. Here's what I'm hoping for somebody who wants an A+ in the calc. A project for you. A project. You guys want to hear me? For somebody who wants an A+ in the calc. Here's what I'm hoping, and I had a dream for a while about this one. To do, been dreaming about it. You can think what Chad dreams about. I'm hoping with an Excel sheet that can calculate all the panels in the building for us, the industrial panels. That's what you guys are doing for me. One sheet that calculates all these. When I say calculate the panels, guys, it will find the panel size, the overcome protection device for the panel, the equipment grounding conductor, the ungrounded conductors, the neutral, the grounded conductor, yeah, the grounded conductor, and the conduits that you can put all these in. That's, you guys have to do this. This is part of the project for every single panel, part of the project. Here's what I would love to add in the same sheet, guys, or in a different sheet. Since you guys are inputting all these loads, Muhammad, all these mechanical loads and owner equipment loads and all this stuff, what I was hoping is to do a sheet or part of a sheet that does the calculation for the branch circuits. For example, you have the tube mill. You take that tube mill, multiply it by 1.25, and that will size the overcome protection device for the tube mill in Excel. And also the conductor, the SO cord that's going to go for that tube mill. So do the branch circuit calculation. Another example is to take to do calculation, guys, in Excel that size how many lighting circuits we can do, how many lights we can put in a 20 amp circuit. Some calculation that does that. Take the volt amp of the fixtures that you guys have, divide them by, add them up, divide them by the voltage, divided by the current, and that will get you how many and 0.8, and that will get you how many fixtures you can put on one 20 amp circuits. So doing calculation, guys, with a branch circuit calculations using Excel for every machine, especially for the machines, guys. Take the air handling unit, Spencer. You take the air handling unit full load current. You do the in Excel, the size of the overcome protection device for it, the size of the feeder, and so forth. Not required by me, but if anybody wants to jump into this project, I will help you as you go through. There's some code related. And as you size the branch circuit for the sheet, the branch circuit for the air handling unit, you will tell me exactly where you found the code, all this information is there, guys. We've done it. It's just I've never been done in an Excel sheet. Adding branch circuits to the Excel sheet. If anybody can jump into this project, I will be able to help you. Okay, let me tell you what my situation here is. I do have a situation. My situation, my friends, is I need a panel. Here's my panel. I'm bringing my feeder to feed this panel. It would be nice if the panel engulfs the feeder. So I have, here's my overcaptation device. Here's my panel. As you guys know, inside my panel, there will be, this is a panel. Alright, how many colors? The panels. Inside my panel, I need to size the following. Here's my ground. Here's my neutral. Woodman grounding conductor. I'm going to use another color to take the neutral back. This is my neutral. This is my phases, 3 phases. I need to size the bonding jumper between the two. You can see that bonding. This is my main bonding jumper. Oh, make it bigger? Yeah. Okay. Sorry, one. Alright, let's we have the whole, how about if we have the whole board? Why would we go limit ourselves to that better? Thanks, buddy. Here's my neutral. Here's my ground. That's inside the panel. I'm going to tie these two guys together. Okay. I'm going to have a neutral that's coming from here, going back. From the ground, I'm going to go to Mother Earth. And so this is inside your panel. Are we missing anything? No. So my neutral bar, my ground bar, my equipment grounding conductor, my neutral, and my phases. I want to size all these for a panel. Let me just tell you a few things about this. Everybody knows there's a conduit here. There's a conduit, and this is bringing all these conductors inside the conduit, right? Can you guys see that? These are conduit bringing all these conductors inside that conduit to a panel. Everybody see what we have? We have a panel, and we need to size a few things for the panel, exactly what you guys are doing. Except here's what I'm going to start. I'm going to start by telling you the following, guys. This is actually a lighting panel. Lighting panel. And the voltage is 480/277 volt. Okay, so that's given. The second thing that's given, guys, is the load. The load in this panel, I'm giving you a load of 150 kVA. So I'm giving you guys a system, like exactly, Brad, what you guys are going to be doing. You find the kVA, already derated, added, multiplied by 1.25. Everything is already taken care of this. Don't worry about that. I already added all the volt amps of all the fixtures, multiplied it by 1.25, and I'm giving it to you guys as 150 kVA. The system is 480/277, and of course I don't want to mention, but I will. It's a 3-phase system, so don't get confused. It's a 3-phase system. From now on, guys, everything that we do is 3-phase system. We don't do single phase. We don't do single phase anymore. 3-phase system. Okay? And I need to calculate the following, guys. A few things for this panel, Mr. Beck. A few things I want to calculate for this panel. Let's do, I'm going to use red, guys. Red is my color to what I need to calculate. Red. Okay, so first I'm going to calculate this one, number one. Number one, DJ, is actually the panel size. I will write them. Number one is the panel size. Number two, guys, is the overcurrent protection device size. I will calculate the overcurrent protection device size. The overcurrent protection device size. Okay, the overcurrent protection device size. Number three, as you can imagine, is going to be the ungrounded conductor. Number four is going to be the neutral conductor. The neutral conductor. Number five, are we at five? Number five is the grounding electrode conductor. And number six is the main bonding jumper. The main bonding jumper. The main bonding jumper. Can you guys follow with me? That's exactly what you're going to do for every panel in this building. And to make things more interesting, I want you guys to go to size the conduit too. Number, that would be number what? Number 7. Thank you. Number 7 is the conduit size. And when we reach what type as we go through, we'll tell you what type I want you guys to size it. This is typically what we do for any panel, guys. Typically what we do for any panels. Typically what we do for any panel. Now, Spencer, disclaimer. The continuous load has already been incorporated in the 150. So some of you will ask me, Chad, what happened to the continuous load? Did you guys hear my disclaimer? I already added all my volt amps, multiplied it by 1.25, and I came up with a big chunk of 150 kV. My load. I need to size a panel. Everybody heard that one, guys? But you're going to ask me, Chad, what happened to the overconduction device? To the continuous load. It's already added. And I gave you the lump sum. Okay? Now let's, I need somebody to keep telling me what the number is. So we went 1, 2, 3, 4, 5, 6. Okay. Any question, guys, about the requirement, Mr. Bev?
What's 6 and 7?
6 is, by the way, as I write them down, I will write the name too. 6 is called main or system bonding jumper. The technical term for it is system bonding jumper. System bonding jumper. And grounding electrode conductor is 5. System bonding jumper and grounding electrode conductor. Any question, guys? Any question, my friends? Yeah? If you can find us a filter, man. See how I'm slow today? Okay, let's go for number 1. Number 1. I want somebody to tell me what was number 1. Number 1 is the panel size. Panel size. Okay, for the panel size, my friend, I want to take I, always in I, divided, what was the size, 150K, right? Divided by 1.73 times 480. It's a 480 panel. So if you guys did the math on that one, you're going to find, what did you guys come up with? 180? 180 amps or 181? Go up on the fraction. What was the fraction? 180. Okay, 180 amps. So I have 180 amps. 180 amps. You're going to take this one, my friends. So 180 amps. Take it to DeWalt. Now we're going to be using DeWalt because these are panel sizes. To 3-12 DeWalt 3-12 under panel boards. Panel boards. Under panel boards from DeWalt. If you guys look at 3-wire single phase, 4-wire, My next standard goes from 60, 120, 150, 200. Did you guys see that? Everybody can see that 200?
Where did you get 150K from?
The 150K is the load that I gave you.
Oh, okay.
The load. So if from DeWalt, guys, everybody can see that we can buy a 200 amp panel. So I bought my 200 amp panel. So what size is the cover inside the panel? That's the cover inside the panel. 200 amp. Where would I find these sizes, guys? Directly from DeWalt. That's piece of cake. Number 2, overcurrent protection device for the panel. Overcurrent protection device, guys, the same calculation. You're going to take the current I equal 180 amps. You're going to take it this time, DJ, my friend, you're going to take it to NEC 240.6. What's the next standard? Do we have 190? No, so it's 200. So, perfect, 200 amp. 200 amp. So we size a 200 amp. We size it at 200 amp. So my panel is 200 amp, and my overcurrent protection device is 200 amp. Doesn't have to be. Sometimes the panel is bigger sizes, guys. You could have a 600 amp panel broken at 500 or 400 amp because of the load. I can't emphasize, guys, the continuous load has been incorporated in the 150. In the 150. So 1, 2, 3 is the conductors. Any question, guys? Any question? Any questions? DJ? Any question about that? Okay, let's go to the third one. Number 3. This one is, I'm going to call them, in this case, this is a service panel. I'm going to call it a service panel. So these are ungrounded conductors. Conductors, aka the 3 phases. 3 phases. The ungrounded conductor, the 3 phases. I'm going to take the same. Now, here's a moment of truth. A moment of truth. My current, guys, is I equal 180 amps, right? My overcurrent protection device is 200. The code, Brad, allow you to size based on 180. We're not going to do that. It's not a good engineering way. A good engineering way is to match the overcurrent protection device. But I want you to be aware that you can size based on 180. In this case, it's going to be the same, but sometimes it could not be. Okay, so moment of truth, I want to say match overcurrent protection device. So I have 200 amp. I'm going to take them to 310.16 under 75-degree column. So I have 3 conductors. What size? How much? 3 aught. 3 aught. And suppose we are coming underground, guys, in the PVC. Let's make them THHW. 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 Huh?
Yeah, then you gotta go to a different column.
THHW.
Further down. What location?
Yeah.
And you gotta go to 75 degree column.
Yeah, we still.
That's where
We're not derating anything. There's just three.
Sizing.
That's all right. So three conductors, we are THHW. Any questions about the ungrounded conductor, guys? And could you please, right next to here, just see CSK. Every time you see the CSK, that's charge opinion. Code, you can size based on that 180. 180. Okay. What's the third one?
Neutral.
The fourth one is the neutral. Muhammad, are you guys done?
Yeah.
Mr. Beb?
Yeah.
Wearing hats forward and backward, and what's going on here? 4. Number 4. This is rounded conductor, aka neutral. Rounded conductor, aka neutral. AKA neutral. Any question guys about this? Any question? Okay, for the neutral, without missing guys with the neutral. Here's what let me just put a disclaimer for you. For panels equal or less than 225 amp, use full neutral, and next to it CSK. So I'll tell you, where did you get that one? Anything guys, 225 amp panels is a good idea to use full neutral. Because of harmonics and because of a whole big issues. So the second component, if panel more than 225 amp, then the first 200 at 100% over 270%. Where would that? This is I have to write the code.
22061.
Yep, 22061. Thank you. This is 220.61, and in particular B, I believe, permitted B. In particular B. So this is what I would use, guys, without messing around, Spencer, of trying to find what is the neutral load and what's not the neutral load. It's not worth doing the exercise. Okay. Can you guys write these two rules? Anything 225 amp, don't even mess with it. A full neutral. Based on this, Muhammad, my friend, my neutral would be, so I'm just going to write, based on this rule, my neutral in this case, I need conductor, one conductor, number 3 aught, based on AWG and THHW. Okay? Based on this rule. Anybody can disagree, guys? So really, no, you can't apply this rule for it. Even our panel, you can't apply it. It's less than 200 amp. So we pulled full neutral. We pulled full neutral. Mr. Bell, we pulled full neutral. What I like about this one, guys, this is typical for every panel that you guys are going to size in this project. Typical. The every panel. I want to take a panel that's going to be larger than this, and I'll tell you how we're going to do it. Any question, my friends? What was the fifth one?
Grounded.
Grounding electrode conductor. Can I move on? Other than bread, can I move on?
Yes.
I can go over again. Number 5. Number 5. Okay. This is grounding electrode conductor. Grounding electrode conductor. This is the term, the code term for this baby. Grounding electrode conductor. 250.66. If you guys go to 250.66 article as well as table, here's what it tells you. This is 250.66. Okay? So it tells you take the ungrounded conductor size, which is 3/0 AWG, and we're all in the copper company. Go to table 250.66, and if I don't tell you guys anything, it's assumed copper. And Spencer, what's the size? Did you come up with the size?
4.
Thank you. How many? 1. Thank you. Number 4. Spencer, as long as I'm harassing you, what insulation type?
THW. THN. I don't care. Use what you want.
Fair.
Gotcha. Huh? Okay. You can, by the way. Okay, by the way, you can. I just want to see if you're awake. By the way, you are right. You can have a THH.
Yeah.
You can.
You see, I just see.
You can. So I didn't mean to put you on the spot here, Spencer, but you're my friend. So a bare conductor. A bare conductor. But I can have it insulated or covered glass. I can. Number 6. Number 6, guys, it's called main bonding jumper. Main bonding jumper. That's the technical term for it. 250.28, right, Holly? 250.28 D. Main bonding jumper. The article for this one is 250.28D. If you don't believe me, ask my grandma. The article for the bonding jumper. Oh, by the way, the bonding, guys, I have really good exercises for you about bonding. It's coming by itself, but this is just part of a system, just where it fits in a system. Main bonding jumper. Why main bonding jumper? Camille, my friend, the assumption is this is a service panel. What is the service panel? The service panel is the first panel where the power conductors land in. That's called service panel. That's my assumption. It's not a sub panel. If it was a sub panel, I don't have a main bonding jumper. I wouldn't have a main bonding jumper, and I wouldn't have a grounding electrode conductor. I would have an equipment grounding conductor, which I have an example for you. This is a service panel. Am I right? Everybody got that one? Service panel? Okay, so from there, if you guys, my friend, if you go to this, it tells you the same thing. Go to, take the AWG, take it, guys, to table 250.66, and I'll get you one conductor, number 4. What type of insulation, Spencer?
You decide.
Anybody can help Spencer? What type of insulation? Main bonding jumper. What type of insulation again?
Fair.
Bare. What happened to you? You can. These guys, these are bare. They don't need to be insulated. They're grounding. They're bare. They're bare.
Can you just eat this?
Can I put bare here? Bare. So emphasize it. Bare.
You can just match it. Is that what you're
You know, Spencer, you know why I'm asking this? Because you're going to find a smart aleck electrician when you go to the field and they say, oh, by the way, you, Mr. Designer, and he'll do it to you. and say what installation should we use for the system bonding jumper, just to trick you, right, Holly?
Mhm. You see it all the time.
You've probably done it a couple of
Then you
times.
can say, did you take the test? Look it up.
There.
Not doing your job for you. Any number.
I had a guy ask me about the length of the screw just to trick me as an engineer. Length of the screw that they put in this hardware. Are you kidding me, man? Am I a hardware guy? And you really, if you don't use it day in, day out, you wouldn't know how long is that stupid screw that goes into this hardware piece.
Either 632 or 832 or.
I don't know. So, okay. Any question guys about this? Number 6. DJ, what's after number 6?
7.
What is 7? I know what's 7. What's 7? Conduit?
The EMT.
Conduit. Number 7. Number 7. Conduit size. Since we guys are coming underground, I have to tell you what type of conduit. It's a service, so I want to bring it in a PVC Schedule 80. Otherwise, you wouldn't be able to do that. And the type is PVC Schedule 80. So let's go. How many conductors do I have, guys? I have 4 conductors. Number 3-aught. Take this one to. So since all of them are the same, we're going to go to Annex C, right? Help me here, guys. Annex C. NEC. Annex C. In particular, which C, guys? C9. Thank you. C9. And remember the installation, guys, is THHW. Anybody can tell me how many I need? 2 gentlemen or and a lady, or 2 gentlemen? 2.5. Other than those 2 guys? 2.5. Anybody disagree? Camille, what did you guys come up? 2.5. 2.5. Okay, 2.5 it is. 2.5. 2.5 what, Brad?
Sorry, what?
What's the unit? 2.5
Inches?
inches. Thank you. Not squared millimeters or something? No, that's mud, Alec, huh? 2.5 inches. 2.5 inches.
You could use 40 for ground keeping.
You can use what?
Instead of 40.
Well, we're assuming we need physical damage. I chose this one.
No, but you could use
Yes,
40. though.
yes.
Okay.
If it's not exposed, but when you go underground, at one time you have to come out above the ground. That's where they catch you on the. Then you need it
If it came out of the
right
ground
into the switch.
the
Yes,
switch
yes,
gear,
yeah.
then
80.
You'd still have to
Yeah.
use 80.
No,
Oh, you could use 40. Not
Absolutely.
if it wasn't exposed to the
absolutely.
ground.
Unless it's not exposed to physical damage.
Oh.
Okay. What is number 8, Mr. Bell?
We don't have one.
Do we have number 8?
No. Number 7 was it.
Number 7 was it? Okay.
We're done. Buy your panel.
Any question, guys? So hopefully that will apply for every single panel that you guys have in the main panel. That will apply to the main panel. Let me just take one more example. Example number 2. Example number 2. I need a mechanical panel. I have a big fat mechanical panel. Big fat mechanical panel. Big fat mechanical panel. And I have the same thing, since I hope this will ground. Did I put the neutral at the top? At the beginning one? Yes, okay, so they just be consistent. Neutral, ground, bond these 2 together. Take the neutral here, take the ground to Mother Earth. And what else did we have? And then a conduit. Then we have a conduit coming in here, and a conduit coming in here, and here, and here. Okay. This is, I'm going to call this one, guys, mechanical panel. Mechanical panel. MP. Okay? The size in this mechanical panel, as I calculated, I took the everything, the continuous, non-continuous, everything else, and I came up with 1000 kVA. 1000 kVA for this baby. 1000 kVA. It is a panel, it's not a service. It's a panel and it's not a service. It's a panel, it's not a service. Some panel. And the voltage system, of course, on a system like this, the voltage is 480/277. And it's three-phase, of course. Are we missing anything? I gave you the load, the voltage, and we need to size the following. Give me, guys, the first way we numbered it. This was number 1. This was number 2. Did I number that one 3? Right?
Yeah.
The neutral was 4.
4, yeah.
Thank you. I just want to be consistent.
Cheese.
This one was 5.
Yeah.
5. And this one was number 6. Number 7 is the conduit. Thank you, my friend. May God bless your heart, man. Number 7. There you go. These are the same 7 things, guys, for a mechanical panel. Exactly what you guys are going to be doing. Yes, sir.
Same for all the panels.
Yeah, the same calculation. These 7 steps that you guys did, it's going to be identical for all the panels. Spencer, any question, guys? I want to remind you, it's not a service, it's a panel. So what would that give you, Spencer? There is no grounding electrode conductor in it, and no system bonding jumper. No grounding electrode conductor and no system bonding. Well, why am I putting a system bonding jumper in then? Oh, that would defeat the purpose. Let me just retract, guys, and make a service. Service panel. I like you because I really want to do some calculation, nice calculation here. Call it service panel. It is the mechanical panel and the service panel at the same time. This is coming, guys, if you have a wastewater treatment plants, that big mechanical panel would be everything in one. All these pumps will be going. So this is just to do some exercise on the grounding and bonding. Okay, let's do it together quick, Mr. Bab. What do you think? Everybody got the info? I know Camille and Jim, are you guys doing the Excel probably? Doing the calculation with Excel? That's good. Number one, what did we say number 1 we're going to be? Panel size. Panel size. The panel size, guys, I equal 1,000. I need somebody to give me K divided by 1.73 times 480 equal. How much?
12,400.
I didn't hear. I'm sorry.
Yeah, 1,200.
1,200 or
12,300.
Go if it's 0.5, go up, guys. That's yeah.
0.8.
Yeah.
It's actually is 0.3.
Okay. 0.3 or we need
12,4.
1204.
Yes.
I didn't.
Okay. Don't confuse me, guys. It's Friday. Anything 0.5 or higher, just go up. We're not going to fight. It's going to not make a whole lot of difference.
Well, it's not going to make a difference.
Disagree? Anybody disagree with my friend Ben?
I do. I got 12,3. I disagree with myself.
1204. It's not going to make a difference as you can see. Take it to D Walt 312, right? 312. What's the size of D Walt? You're not going to find a panel, so you're going to go to 313. You're going to go to D Walt 313. D Walt 3-13, which is right here, guys. You're going to go under 3 phase. I have 1200. Gosh, I'm so close. And a 1600. This is a decision when you scratch your head and say, should I go for 4 amps up? Gosh. Or should I stay with a 1200 amp? For 4, you know, let's just do it the engineering way.
That's low.
1600.
We already took that. We already took that. Future expansion. We already took that. You're absolutely right. These are, if I took continuous load, a future expansion, and everything have been taken care of, guys, honestly, for 4 amps, I would go down. Okay? Did you guys hear me? Everybody got the message?
Go down.
So I'm gonna go down to 1200 amps, just because of this scenario, guys.
What would you have to do?
What's the cutoff that you can go?
Where, there's gotta be a line that you draw on the sand somewhere. That says,
Oh,
I'm
what's-
at 1210 now, but I'll just go down to 1200. So
Yeah.
where's the-
When it's over 800 amps.
You know what? For 4 amps out of the 1200 amps, I will go down. What's the cutoff? Let me give you a cutoff. 10%. Use 10%. Really, 10% is a good cutoff. If you want a commitment, 10%. So if you are 10% higher than a panel size, go up. If you're 10 or less, go down. More than 10, go up. Does that make sense? That's Chad's rule. I think it makes sense because if we are 90% on all panels, okay? So we put it down here, 10% rule, 10%.
CSK.
Cut off CSK disclaimer. So if you send it to your boss and say, who's that idiot who told you that? CSK. $1,200. Any question, guys? So definitely in this situation, definitely, I don't think you would find 2 engineers disagree that going down. Especially, Ryan, if you took future expansion in and continuous load. You already oversized the panel, guys. We already oversized the panel. Okay, so that's number 1. For the test, if you guys do this one and you tell me, Chad, you know, value engineering, I'm gonna go down. Actually, you tell me that you know what you're doing, and that's great. Even though you went down and you said value engineering, blah blah blah, you convinced me.
Did you say value?
Value engineering. This is a term for doing whatever you want to do, basically, because you have a chip on your shoulder. Until somebody sue you and you lose your house. They hire somebody like Ryman and say, no, see a chat code in the front of the judge and you lose your house.
Also, CSK told us to do it that way.
CSK didn't, I lost my house. We have a lot of, sorry, Muhammad, did you finish? Number 2. Let's do number 2, guys. What was number 2? Ungrounded conductors. Thank you. Overcurrent protection device. So what was the size we have? 1204 amps. We're going to take this one to 240.6 from NEC. What was size? Do we have 1200?
Yeah.
Now, this is again, should I go for the Nexus 1600, Spencer, right? Should I go 6? No, you don't have to match. These where you don't have, you're going to see, you don't have to match these. Because sometimes, guys, the panel size is very large. You don't have to match it. The conductor, you will. So this will be 1200 amps. Now, is it wrong if you match them, Spencer? No. But sometimes you really end up with an 800 amp panel, guys, and all what you need is just 600 amps out of that. Should I jump 200 amps higher? That's a third more. What's the problem with jumping? The problem is now you have to carry an overcurrent protection device that match that 800. Your overcurrent protection device will be more expensive, and the cables that you bring to the panel will be more expensive. Because, guys, we size the conductor based on the cable, not based on the panel. The panel cover is one thing. The overcurrent protection device is how we size the conductors based on. Okay, what's number 4? Number 3? Is ungrounded conductors, the phases, 3 phases, right? The 3 phases. That would be the same thing, guys. We said we match overcurrent protection device. 1200. 1200. How many runs do you guys want to run? Divide by 4. Give you 300. That's a good way, right? Divide by 4. That will get you 300 amps. Everybody in second nature, what I'm doing here, 1.16. Divide under 75-degree column. 350? 350? How many? 3 conductors, 350 kcm. Let's assume this one is going to be a THHN. Let's assume it's going to be a THHN. And how many sets? I'm going to write the sets. 4 sets of. That's how you're going to write it. So that's your full complete answer. 4 sets of 3 conductors. Each one is 350 and the insulation is THHN, kcm. Any question, guys, about this piece of cake? 4 sets. Mr. Bab? Any question, my friends? Move on. Let's move on. Hello? What are we here? I'm going backwards. Why? Doesn't want to go forward. Okay. Try to be smart. Alec here doesn't want to get me. Why didn't we? Okay, here you go. 3, 4. Number 4, my friends. Grounded. Grounded conductor. Grounded conductor, guys. Here's what I would do with the grounded conductor. Take the 1200 amp that you started with. Take my 1200 I. I'm going to say, here's what I would do. I start with overcurrent protection device, the same thing. Overcurrent protection device equal 1200 amp. Okay? Then take the 1200 amp. The first 200 amp, what do you do with them? Leave them alone. Then take the 1200 amp minus 200 amp and multiply these by what? 0.7. And like my daughter always say, put the plus. Well, since we are in America, we put the plus on this side, don't we? All right. So add the plus in this here. What would that give you? 900? Thank you. 900 amps. I want to make sure everybody knows what this calculation is, guys. 200 alone. Take the 200, that will give you, that's easy. 1200 minus 200 give you 1000. Cut it by 7700 plus 200, that's 900. That's easy calc. Okay, since Ben, how many runs did I run for the phases?
4 sets.
Did they say 3 sets or 4 sets? Then I have to run these, how many sets? 4 sets. I'm stuck now for the sets because how are you going to run them together? You have to parallel them. So unless you run them in a separate conduit, like all the neutrals in one conduit. If you run all the neutral in one conduit, you can parallel 2 sets. If you put all your neutrals in one conduit. If you put the phase and the neutral and the equivalent ground conductor in one conduit, then they have to be run the same set, the 4, 4. Okay, so in this case, we're putting them in the same conduit, guys. So I'm going to go 900 divide by 4. What would that give you? 225? 225 amp. Take this one to 310.16 under 75-degree column. What would that give you?
4.
How many?
4.
How many?
4 sets.
4 sets. Thank you. 4 sets of 1. 1 for hot A, W, G, T, H, H, and N. That's a complete answer. 4 sets of 1 conductor, AWG, THHN. The insulation is a big deal. Oh no, I will size the conduit now. What's number 5?
On the left, or the other one.
GC.
What is the conduit size? One is the 6?
7.
7? Okay, the last one. That's good. Thanks God. Any question, guys, about this? Spencer? Piece of cake. All right, let's go to. I'm sorry, Mohammed, my friend. We're good? Mr. Bab?
Yeah.
Okay, number 5. Number 5, my friend, is what was number 5? Grounding electrode conductor. We put, guys, we know where to find these 250.66. Okay, grounding electrode conductor. It says you do the following. How many sets do I have? 4. I'm going to say a number of sets times ungrounded conductor size. Okay, so this is what we're doing. Number of sets are 4 times what's the ungrounded conductor size?
250s.
250.
350s.
350. I want 350, guys.
You said
350 kcm equal. What's 4? 7, 1400? 1400 equal 1400 kcm. From here, you're going to go to table 250.66 and how many conductors you will need and what size and what insulation.
Need
One conductor,
3 aught.
3 aught, other than Brad, anybody disagree? 3 aught? 3 aught, number 3 aught. And what insulation? Bare, minimum insulation, bare. Any question, guys, about this? Did that help when you say number of sets times the ungrounded conductor size? Because we're running sets now, 4 sets.
Take a 5-minute break, Ted.
Yes. Let's take a 5 minutes break. You guys make coffee? Did you find coffee?
Yeah.
You're the best, man. You will get your D- as a minimum.
Somebody comes to ask me about some guy in a black hood speaking for classroom. You won't tell her yet. No, it was in the motor room. Yep.
So I can hear. Go ahead. Okay, you take the number of sets.
I was gonna say,
Yes, the ungrounding not the neutral.
so, you know what, send them back, send them, message back and say, okay.
But there's consistent bonding there is different.
Calls out.
No, I can't say that.
So I would give you 20.
1 second.
You're
I know you guys want to do work for Chad, so I'm going to keep going here in a second. Thank you, my friend. No, this way, this way. What is this? Why am I going to this?
Oh,
3 sets. Okay, number 5. Number 5. Number 6. What's number 6, my friend? Number 6. Main bonding jumper. The main bonding jumper, you do the same thing, you guys. You take the 4, multiply by 350 kcm equal 1400, right? 1400 kcm. If the 1400 though, kcm, if it's more than 1100 kcm, then you do the following. Is the 1400 more than 1100? I hope so. If your answer is yes, then you're going to do the following. And by the way, all this is in 250.28d. You guys don't believe me? So you take 4 times 350, 1400. Is 1400 more than 1100? Yes, the answer is yes. Do the following. You're going to take the 1400 and multiply it by 12 and a half. 12 and a half. 0.125. 0.125. And if you, all this, guys, the code says if it's a main bonding jumper, if your service conductors are more than 1100 kcm copper, then you take 12.5% of the size of the service entrance conductors, all of them. Spencer, makes sense? Only for the system bonding jumper. Only for the system bonding jumper. 12.5% of the service entrance conductors put together. All the parallel, not the phases. Well, I don't want you guys to start adding phase A with phase B with phase C. If phase A, take one phase. How many? What's the size of this conductor? 350. How many runs of this phase do I have? 1 runs. Then don't multiply by anything else. In this case, how many runs of every phase do I have? 4, which is a 4 sets. Yeah. So you multiply by 4.
But you don't take the individual.
No, you don't. You don't. You take the sets. If the sets here was 1, if we only parallel, if we're not parallel, this number will be 1. That's why you multiply by 4, guys. These are the number of sets. Number of sets in parallel, and number of sets in parallel. Number of sets in parallel.
So it'd be like 4 reds.
Yes, thank you. 4 blues. Yeah. But you don't add the red to the blue to the brown. Color coded. Okay, anybody did the math for me here? 175 kcm. Okay, now I don't know about you guys, but what is 175 kcm? Take this one to chapter 9, table number 8. What's the next standard next standard cable? 4/0. How many do I have? Do I need? Hey, bud. How many do I need?
1.
How many do I need?
1.
Holly, 1. Thank you. 1 4/0. Anybody dares to disagree with my friend Holly? Everybody knows how to go to table number 8, guys. Then Muhammad, when you go to table number 8, my friend, you need to make sure that your KCM of your cable is 175 or higher. 175 or higher. 175 or higher.
Table 8.
Chapter 9, table 8. Anybody knows what the page of that baby?
It's 81.
681. Thank you, ma'am. So if you guys
Or
go,
the new code 721.
okay. DJ, can you take them outside and take care of them? I mean, not he take you, of you. 170, 165, 170. Okay. 1, 2, 3, 4. Yep. So you're gonna take all the way to 4/0. Yep. So what? Because 167 and 175. 4/0. What insulation, Chanel?
Bears.
You got me. Yeah. You are awake, Janelle. I thought you just made the coffee and went to bed. You're awake, man. Any question, guys? I mean, bonding jumper. Did you guys have any, Brad?
Why is it larger?
Because guys, this is 175,000.
Yeah, no, I understand the size that you came up with.
Yeah. Why is it larger than the grounding electrode conductor?
in 250.66, it says over 1,100,000.
Yeah.
So why is it 4 and not, I
3
don't know, 3
Because if you go to 250.28d,
Okay.
if you go there, it will tell you if you are larger than 1100 kcm, then do 12.5%.
No, that part I get.
Yeah.
1,200 kcm.
He's wondering what.
12.5% of 1,400 is 175.
Yes.
So why wouldn't you subtract the 175 from 1,400 and get 1,225 and then go back to 250.66 and put a 3 on it?
Because they didn't tell us to do that. That's all. Because they didn't say that you could, but the code says you take this number, multiply by this, whatever you get here is your size. Either you go custom design at 175 or you go to the next standard down. Yeah. Well, how did you come up with this calculation? You subtracted just Just curious to see.
The DeWalt book, and
Yeah.
our total service entrance conductor area would be, you're essentially derating by going 12.5%
Yes.
less. So
Yes.
if you take the 12.5% less the 1,400, it would be 12.5. Go to the table,
Huh.
and it would be 3 off.
It just doesn't say. Yeah. That's it. It just that you have a point, but that's how they do it. This is where if you get sued, you can keep your
Well,
house.
because it's bigger than your grounding electrode conductor, so.
Has to be.
Yeah, either way.
Yeah.
Why wouldn't it just be the same? Because there's enough.
Ah,
current capacity.
Now that's a different story. Why it's bigger than grounding electrode conductor? There's an answer for this.
Okay.
Because if you can see, let me go tell you why they make them. That's a whole different story. If you go back, if you guys see, can you guys see that this is the neutral here is bonding the ground? So if you lose your neutral, then this piece will act as what? As a neutral. So they want it to be sized larger. And the grounding electrode conductor, guys, these grounding electrode conductors are one of many. You will have multiple grounding electrode conductors. So they want to make sure that it can handle the neutral load upon the loss of a neutral. So they size them a little bit more. Because say I had a storm and I lost my neutral. Lost my neutral only. If I'm bonded, then all the neutral current will go through the bonding jumper down to Mother Earth all the way. But you will have multiple of number 5, but only one bonding jumper. So, good point though. Okay, what's number 7, Mr. Bell?
It's the conduit.
The conduit. Now the conduit, I want you guys to wake up. Let's do that one. Number 7. Conduit size. I decided to put them in a rigid metal conduit. Okay, let's see how many conductors we have. We have 3 conductors. Number, what was it? Number 350, right? 350 kcm. And 1 conductor number. What was the other conductor number? 3 aught. The neutral. What was the neutral size? 4 aught. 4 aught. AWG. Now we want you guys to take this one to chapter 9, table table 4. What's the crust? It's the insulation. Yeah, the insulation. Insulation for both of them is THHN and also THHF. Okay. See how we guys did it? Let's go to table number, what did we say, table number 4? No, I'm sorry. Table, for this one, you need to go to table number 5. Table number 5. Okay, if you guys go to table number 5, and we need THHN. Anybody found THHN? Number 5, THHN, Chad. Okay, it's in page 678. THHN. And what was the size? 350? 350. Anybody disagree that it's 0.5242? Did you come up with that? 0.5242? You come up with that?
If you say so.
Anybody come up with? I just want somebody to acknowledge it.
Yes.
Okay, 0.5242. 0.5242. And how many multiplied by what? Multiplied by 3. And let's do the 4-aught. The 4-aught, buddies, 0.3237. 1 times 0.3237. Right? Thank you. 0.3237. And what do you do with them, Mr. Bell? Add them up. Anybody did the math for me? Anybody want to do the math for me? You guys want me to do the math too? 3 times 0.5242 plus 0.3237 equal. I have 1.89. 1.8963 square inches. Okay? Anybody guys disagree? Anybody did the calculation different? Then you're going to take the 1.8963. It's a rigid metal conduit, table number. Which table this one? 4, chapter 9. You're going to go find the cubic square inch of this amount under which fill? By the way, which fill?
40%.
Under 40%. 40% fill. This is just a quick reminder how we did the fill conduit fill calculation. So rigid, everybody found the rigid mill conduit, yep, right there. So it's 40% fill, what did we say? 1.8, 1.9. I came up with 2.5. Anybody came up with different than that? 2.5. So that will get you how many conduits? How many conduits? 2.5 inches. Rigid metal conduit. How many runs? 4 sets of. There's your answer. I have 4 sets of 2.5 rigid metal conduit. 4 sets of 2.5 rigid metal conduit. Let's put them in order. 4 sets. 4 sets of 2.5 inch rigid metal conduit. Rigid metal conduit. Any question guys about this?
How do you do the 4%? What's the 4%?
Mr. Beb, if the code says if you have more than 2 conductors, you go to 40% fill.
40. Okay, yeah.
That fill.
I thought it was.
So when you go to table 4,
Yeah,
it's
got it.
first chapter 9, table 4. When you go there, you have to pick rigid metal conduit. When you go there, you have to pick the 40% fill. Why rigid metal conduit? Because Chad clearly said so. Why go to the table, chapter 9, table 4? Because the code says so. Why did you say 40% fill? Because we have more than 2 conductors.
What do you mean, UGC? Why do I have that?
Equipment ground conductor. I have one example for equipment ground conductor. Only when it's not service. I'm going to do one about equipment ground conductor. We're going to do one more example. Simple one. What's going on with you guys? These are cool stuff. A Friday. No wonder why China is taking over the world, man.
Or it's Monday.
I just gotta make sure I get my load shown.
Oh, you will do. We still have a few seconds here. I'll speed with that one. I'll speed through that one. It's going to be a repetitive. I just want to make a receptacle panel. I want to size a receptacle panel for you guys, right? So because it's 208. The same thing. It's really easier. There's not going to be pedaling because it's going to be small.
Using RMC on all the panels.
Rigid metal conduits? No. We're going to use EMT everywhere, above ground, PVC underground, anything service rigid. If it's above, PVC schedule 80 for the service, PVC schedule 40 for anything underground, above ground EMT in our project. That's the best way to do it, I think. Number 7. Number 3, okay, example number 3. There you go, buddies. You guys are going to be expert with that baby here. You're going to have a neutral. You have a ground. Now, this one is different. This one is different. Here's my ground. And here's my neutral. Okay. I don't have a bonding jumper. And this is, I have 340, well, let's just do some realistic number here. Let's do a realistic number, guys. 210 kVA receptacle panel load. Voltage is 208/120 volt. Can you guys see that? I have, huh? 210 kVA receptacle panel load, 208/120, right? Can you power receptacles with 480/277? Not in America. Not in America. You can. The answer should be now. You're closing your. We're international here, Brad. Closing is here. Not in the U.S. We don't power convenient receptacle with 120. I wish we do. Will save us a lot of hassle. Okay. All right. Let's go find anything else you guys need to know about this panel. This is a typical panel. I want to bring to your attention, DJ, I did not bond the neutral and the ground. I did not bond the neutral and the ground because it's a sub panel. And I did not bring a grounding electrode conductor because this is a sub panel. So this is a panel. I want to see panel, not a service. Panel, not a service. Okay, let's go find, guys, the following. Continue with the same tradition. This is number 1. This is number 2. This is number 3. What was number 4, please? Was the neutral. Number 4. Number 5, what was number 5?
The ground.
Yeah, now we're going to make it number 5 is the equivalent magnetic conductor. What was number 6? Doesn't exist. The conduit was number 7. Here's my conduit. And I'm gonna make number 7. Oops, number 7 continue the conduit here. I'm just gonna continue to make it number 7. Skip number 6 just to kind of get you into the rhythm of it. Okay. So this is a receptacle panel, guys. Receptacle panel, and we need to size the panel. Everybody got the info?
Where's 6?
Oh, 6, no 6.
Oh, I see, okay. No, 6.
I just skipped the 7 to continue with the same rhythm that we were doing. Did you say no sheiks?
Yeah. No sheet.
Any question, guys? I hope that will help you with the panels that we're sizing right now. We're doing the same thing. Ben, exactly the same. Okay, can I move? Now, before I go here, Muhammad, what happened to the main bonding jumper? We don't put a main bonding jumper in a sub panel. No main bonding jumper. Mr. Irbab, what happened to the grounding electrode conductor to Mother Earth? We don't bring a grounding electrode conductor to Mother Earth in a sub panel. Most of the time. There's one exception for that one. We're not going to go there. There is no grounding electrode conductor. Okay, let's go. Number 1. Number 1. What was number 1? Panel size. Panel size. I equal. What was the size that I gave you guys? 310?
210.
I thought 310. You guys lying to me. 210 K V and A. Divide this by 1.73. What's the voltage? 2.8. Thank you. Camille, what's your Excel sheet said?
583.
503?
583.
83. Thank you. 83. I might have to check my vision, my hearing, guys. Now, disclaimer. The 310 that I gave you guys have already been derated. Okay? This is the derated. Remember that first 10 at 100% K, higher than 10, cut it by 50. It's already been derated. So don't multiply by anything else. That's already derated, sized. And that's Ryan, that's where you start. Usually start with the load. You know what your load is, and you size everything from that load. Okay, so let's take the 583 to Mr. D and Walt, and page 3, which is it 213 this time? 2-13, right? You guys help me here, where are you? Did I lose you? Or I actually can do 12 here. I have enough in 12 too. 12. Camille, what would that the size? 583. The next standard is either 400. You go 400 or 600. In a case like this, look at that. See how that one, Brad, how high it is. I can easily go to 600. 600 in. You guys accusing me of going slow today. Good morning, Mr. Bew. I haven't heard you saying a word today. I have to pick on you a couple of times just to hear your voice, man. Any question, guys? Any question, my friends? Okay, 600 amp panel. Piece of cake. Let's go to overconduction device. Grab that baby here. Put it right in here. Number 2, overcurrent and protection and a device. What did we say, guys? Engineering wise, match. No, not match. No, not here. So what's the size? I have a 583 amps. Same calculation. Now take it to NEC 240.6. It'll give me 600 amp, right? 600 amp. So I really landed a good number here. 600 amp, 600 amp, 600 amp. Perfect. 600 amp, 600 amp. $600 amp and 600 amp. One more time, Chad. Any questions, Sir Bell?
Yes.
I have you on record, guys. I can't blame your employer here. Any question? Okay, can I move, honey? You're in a much better mood today than yesterday. Wow, that's good. Number 3. What was number 3, guys?
Ungrounded conductor.
Ungrounded conductor. Thank you, ma'am. Ungrounded conductors. Okay, this is where we say match overcurrent protection device based on, please write CSK here. CSK, that's me. Because you can size based on the load up to 800 amp, guys. Okay, what was the overcurrent protection device, guys? 600 amp. It's a very good idea, Ryan, my friend, to parallel here. Otherwise, you're going to end up with a big fat conductor. So I'm going to go parallel. I'm going to cut it by 2. That will give me 300 amp. If I go to 310.16 under 75-degree column, what do you guys get?
350s.
350s? How many? 3 conductors. Number 3. Let's put them down here. Why are we sticking in that corner here? So if you go this way, that will give me 350 kcm. That doesn't even look like a 50. 350. How many? 3 conductors. What insulation? What insulation? Let's use an insulation that's also, you can, let me use this insulation this time. TH. This is inside, this THHM. It's most likely if it's inside, it's going to be THHM, guys. THHM. Okay. How many sets? 2 sets of. And here's my conductors. So please read bottom to top. 2 sets of 3 conductors, each one of them 500 kcm, installation THHN. Why THHN? Most likely, guys, if you have a receptacle panel, it's going to be inside. Most likely, it's going to be THHN. Not most likely, 99% of the time, it's going to be THHN. Or THHN/THW, one installation. Any question about number 4? Number 3. Number 4?
Ungrounded.
Thank you. Number 4. Number 4 is grounded. Grounded conductor. DJ, I'm not going to ask you how many times you were grounded when you were a teenager. Okay. At least we have one grounded conductor. I bet you were many grounded persons.
So it's stranded.
Stranded. So we take the 600 amp. Here's what I would do. Disclaimer. Here's what I would do. I would take the first, remember the rule? The first 200 amp, leave him alone. Take 600 amp minus 200, multiply them by what? 0.7. And Holly, can you remind me this is 220.60?
61.
61. B or A, I think, I can't remember. 220.61.
B.
B? B. Okay, from this article, who's my calculator? 280. Did you add the other 200?
Yes.
Yeah. You and Mr. Bevan not had it. Plus 480M. Okay, then 480. I have to parallel Mr. Bev. How many runs? 2. Why 2? Because I parallel. We parallel the phases 2. We parallel the neutral 2. So it does make sense, but it makes sense to parallel 5 for some people. I got you. 240, right? Then my friend, check me here. 310.16 table under 75-degree column. What would you guys get? What would we get? 250. I have then 2 sets of 1 conductor, 250 kc and m. Spencer, my friend, you have just got yourself a nice 2 neutral conductors. The grounded conductors are the neutral. Chanel, I'm gonna sign up on you in a couple of weeks here.
GEC.
I don't want to send addendums after
I'll never come back to school again, I promise
you come to visit though.
you. We can correspond through Skype.
Good goal.
Wow.
Figured I was gonna go wire to Israel for a couple of years.
Number 5. Number 5. What was number 5, DJ?
GEC.
Okay, now number 5 is going to change its name. We're going to name it equipment grounding conductor and not grounding electrode conductor. So it's going to be equipment grounding conductor, and that's the EGC. And this is coming from table 250.122, article and table. This is the one that's going to bond and ground the equipment. No service, no grounding electrode. This is not the one that's going to the pipe and the ground. This is the one that's bonding the equipment to the grounding electrode system at the service. Okay, in a case like this, guys, if you go to 250.122, if you don't believe Chad, here's how they do it. They go by the 600 amp over temperature device. Okay, let me just say how they do it. Overcurrent protection device equals 600 amp. Take that one to table 250.12 and another 2. What would be the size? Always cover. What would be the size? 1. 1. How many? Number 1. What insulation type? Equipment grounding, anything grounding could be bare. But if you guys put it in a conduit, they always put them insulated if it's in the conduit. Or covered at least. Number 1, here's another question for you. How many of them? How many of them? I'm going to ask you, how many runs are we paralleling? 2. Then the equipment grounding conductor has to go with each and every one of them. So equipment, so I have to have, I'm going to say just 2 sets here. 2 sets of, because if you have more than 1 set, Spencer, what do? You have to, so 2 sets of 1 conductor, number 1. This is very important, guys. Equipment grounding conductor goes with every set. The same size goes with every set. So if I parallel DJ 15 sets, how many of these conductors have to go? 50. Yeah, that's an easy one. 15 sets. Any question, guys? 1 with every set. And okay. This can be covered, but since we're going to put it in a conductor, I'm going to put an insulation THHN. It could be covered, but I'm putting it in an insulation. I'm going to put THHN. Okay, what number is next? If you guys are, I had number 6, not required. Okay, so number 6, forget it. Number 7. Conduit size. What was the type that I told you guys? EMT? EMT. Let's go use EMT. Okay, Holly, I need you to help me here. What was the size of the phases?
350s.
350s. So how many of them I have? 3 conductors. 350 KCM. You're going to take this one to table number 4, chapter 9, and the installation is T, H, H, and N. Anybody can get me what 350 is? We were there. 0.5. So I have 3 times 0.5242. Anybody came up with something different? Insulation. 0.5242, 0.5242, 0.5242. Thank you. Then the second one, the neutral. What was the size of the neutral?
250.
Thank you. 250 KCM. The same table. That will give me 1 times what? Because there's one of them.
0.3970.
0.3970. Okay? 0.3970. Am I done? I have a grounding conductor yet to pull. I have 1 more, which is grounding conductor. Now, Spencer is going to tell me, Chad, have you lost your mind? We use an EMT and you're pulling also an equipment grounding conductor. Let's assume you don't need to do so, but let's assume we did it anyway. And it's fully insulated. And what was the size of the grounding here? Number 1. Number 1, and it's a THHN. And the same table is going to be number 1 times, Holly?
1562.
Point?
0.1562.
156 and a 2. Add them all up. I came up with 2.1264.
Yep.
2.1264. So I'm going to put the answer here, move it all the way up to here, which is hard to see here. Point two, two, not
You
point.
said 2, man.
Yeah, thank you, sir. 2.1264 square inch. Everybody got that one, guys? 2.124 square inches, 2.1264 square inches. Okay, the last step, my friend, and I hope everybody knows that, guys. You're graduating now. We've done that one in a couple of times. So let's go size a conduit. So remind me, we're gonna go then 2.17, so 2.1264 square inch. Take this one to table number 4, chapter 9, under what? EMT, and also with how much fell? 40%. What size did you guys come up with? 2.5. How many?
2.
Yeah, 2 conduits. Why 2? Because we're paralleling 2 conduits, 2.5 EMT. There's your answer. 2 conduits, 2.5 EMT. Any question, guys? Any questions?
Is this the last example for the day?
Yes. And I promise this time. I want to write the homework though.
I need your assistance.
Just give it away. DJ, take him outside. Let me write the homework, guys. Homework. Homework number 3. Homework number 3. Here's a description of the system that you have. Description of the system that we have. We did mechanical, right? I'm going to have an owner equipment panel. I have an owner equipment panel. The name of the panel is P-1. The load in the panel, in this panel, my friend, is 1,354 K, V, and E. Everything is derated. So that's the panel. It's a panel, it's not a service. It's a panel, it's not a service. And I need the voltage. Voltage equals 600. We're going to go Canadian. 600 divided by 1.73 equal 600, 347. 600/347 volt. We're going Canadian. And size everything, guys, for that panel. And this is based on this will be, guys, based on example number 3. Did you guys hear me? This is basically based on example number 3. Not 1, not 2, example number 3. I have a panel. It's an owner equipment panel. All these machines that you guys have in the manufacturing, that's a panel, not a service. And we have a load of 1354 kVA. The voltage is Canadian voltage, which we use also in the US, guys, 600/347. That's respected voltage. And we're going to find that 6-7 things based on example number 3, please. And homework, guys, are due on Mondays of next week. And please give me homework. It's an easy way of getting 10 points out of Chad.
We just have to show it to you.
You give it to me on a piece of paper, and I'll say okay on it, give it back to you.
You have to tear it down.
Or show it to me on yours, and I'll okay on your, if you want to keep it on your piece of paper. That's fine too.
We have to decide the type of the conduit, or we normally give the type of the conduit.
Why don't you decide the type of the conduit? Use your imagination, Mr. Webb. And how many you're going to run parallel. You're a designer now. You have some freedom of kind of. Let me just give you guys a hint. If you're inside a building, it's EMT is the most common one. THHN is the most common one. So if I were you and I want to hint, probably THHN and EMT. My friends, that's all I have. Thank you for listening to Chad. Sorry I went too far on a Friday.